This video is about making sky colors realistic and stunning, and it's all in my book, Ellen's Guide to Color, Light, and Shading, where the Kindle is only $5. The sky should look lighter than the land because it emits light, whereas the ground receives and reflects light. But is the sky really lighter? I compared the values for this landscape to Photoshop scale, where white is 0% black and black is 100% black. The foreground has the greatest value differences, ranging from 0 to 80%. The midground is narrower, going from 30 to 70%, and the value range for the background is only 30 to 40%, so it trends toward a mid to light gray. For the sky, the part near the horizon is about 20% black, so sunlit white areas on the ground would be lighter. The blue of the sky is actually relatively dark. It's 65% black. But notice that without colors, this looks like a cloudy day. So we're depending on color saturation to make the sky appear light. Here I made a black and white image of the sky and of the golf course, and then I compared their values. And you can see that many of these values are very similar. But why does the sky then look lighter? One reason is that the blue is more saturated than the green, and we tend to think of saturated colors as lighter, even though they really aren't. We expect the sky to be lighter, but this is another interesting thing. It's lighter because it has light clouds, whereas the golf course has dark trees. And why is that? It's called the Bezold or spreading effect, where if you have dark things, it makes everything around it look darker. And I think you can see when I darken the clouds, this blue looks much darker than this golf course, which now has white things around it. Clouds recede in one-point perspective to a vanishing point on eye level, whereas elements on land go up to eye level. Nearby clouds look circular and dark because we mainly see their undersides, and they tend to have strong value contrasts, especially if the sun is behind them. As they recede in the distance, they decrease in size, they overlap, they move down with distance, and they're affected by atmospheric perspective, namely reduced value contrast, indistinct edges, reduced details, and a trend toward a mid to light blue-gray. And they're increasingly foreshortened. And what I mean by that is that their width is going toward the distance. So the width is reduced more than the length, and they become more linear. So this one is a little more linear, and then as you go down here, you almost have lines in the distance. When clouds block the sun, they're uniformly dark with rim lighting along the edges, although they should always look lighter than elements on land. The camera tends to make these clouds darker than they really are, but just don't make them this dark because they'll appear too heavy. Light travels through more atmosphere when the sun is low on the horizon than when it's overhead. And since air deflects blue and violet rays the most, the colors increasingly move away from blue and violet toward orange and yellow, which are their complements. And they're also colors that we associate with sunset. Why are sunsets dimmer than the sun at noon? Well, one reason is the angle it makes with the atmosphere, where light is deflected away. And another reason is that it continually loses light rays as it goes through the atmosphere. The sky is the bluest overhead because it goes through the least amount of atmosphere. But as we look toward the horizon, the sky becomes cyan, then yellow-orange, and finally red-orange. Rather than showing a garish sunset, have the sun below the horizon as I did here, or reflected onto other surfaces as I did here. Now these two paintings aren't my best, but it shows you how you can deal with sunsets. The brightness of the sun here is heightened by its contrast with the dark, dull green land, and between the light and shaded sides of the lighthouse, where I juxtapose two complementary colors with the greatest value contrasts, namely yellow and violet. The yellow side can't be as bright as the sunset because it's reflected light. In the second image, the sense of intense light is magnified by having orange juxtaposed to purple and blue. They're near complements and complements. Remember, we're trying to duplicate light using pigments, so we need to use all the tricks we can use, like contrasts in value, saturation, and complements. And if the sunset is in the picture, as it is here, reduce the color saturation because it takes attention away from the focus, which are the children here, and it makes the painting look garish. At noon, the sky is its most saturated blue overhead, and it becomes whiter as it nears the horizon and as it nears the sun. I compared these colors to the additive color wheel, which I discussed in the last video, and it tells us what happens when we mix colors of light together. So when we mix blue and yellow, we don't get green as we would if we mixed blue and yellow paints together, but rather a cyan or a whitish blue. The main colors during the day then are blue, cyan, and a whitish blue with a little red-violet near the horizon. As the sun sets, we'll see that these colors move away from the short wavelength blue and violet lights toward the longer wavelength red and orange light. When the sun is on the horizon, we begin to see yellow, or this area on the Venn diagram, and we see some red-violet near the horizon. There's enough light to see some of the detail of the fence, but it's dark and it doesn't have much color. Objects further away, like this couple here, become silhouettes, or dark shapes without color or detail. Notice that the sand is also dark because it's reflecting a dark sky. Now, when you paint a sky like this, you would have to put blue next to yellow, and you don't want to mix them and get green because there isn't any green in the sky. So instead, use a yellow-orange or add a little orange here because it dulls the blue and is responsible for these grayish areas in the sky, the mixture of blue and orange. When the sun is near the horizon, it can be orange and red, although with great intensity because it's the source of light. But we can't really reproduce that in pigments. This red, for example, looks heavy and unrealistic. So avoid red in your sunset because the color is too dark and doesn't appear as saturated as orange. When the sun is below the horizon, we lose yellow, so we now see blue-violet, red-violet, and pink. We see faint details for the boat, but little color. And the buildings in front of the setting sun are silhouettes, or dark shapes without colors or details. In the east, with the sun behind us, we see pink reflections of the sunset, but notice this dark band below, and that's the beginning of night rising up from the horizon with the sun behind us. What do you think is wrong with this painting? Well, for one thing, the sky shouldn't be dark over the sunset. It could have blue-gray clouds, but the sky between the clouds is still light. This band of darkness ushering in night would be behind us when we're looking at this sunset. In addition, the sand and water should be dark with little color. Trees look green only if they send green light to us, but orange light contains almost no green light since orange and green are nearly opposites or complements. So these trees receive very little green light, so they can't send that green light to us, and as a result, they look dark. What do you think is wrong with this painting? Well, we can't have an orange sky and purple snow because snow reflects the sky colors. Snow, sand, and water all reflect colors of the sky. In this image, we see that the light area reflects the yellow part of the sky, whereas the shadows reflect the blue part. And over here, the sand and parts of the water reflect the dark clouds. How can we make this image more realistic? Well, the sun shouldn't be a big white spot because it takes attention away from the car, and it should merge with the sky. The ground should reflect the color of the sky, which is blue here. The clouds can be brownish if they block an orange sun, but if we make clouds brown, we risk them looking too heavy because brown is a dull, dark color. So I would avoid brown clouds. And also with blue in the sky, they tend to be gray. The car should have little color or detail. And this car suggests that it's being lit from the left and the right. In my next video, I'll show you how to paint a sunny and an overcast day. And remember to subscribe.